Space enthusiasts are left in complete awe as the world is finally getting major glimpses of the full potential of NASA's James Webb Space Telescope. This time, the James Webb Space Telescope has successfully captured a breathtaking image of Uranus, the icy planet in our solar system. JWST's infrared image of Uranus shows its spectacular rings along with its active atmosphere of the planet. If some of you don't know, Uranus has its own system of 13 nested rings, just like Saturn's rings. These spectacular rings have only been observed by two other facilities: the Voyager 2 spacecraft when it passed the planet in 1986, and a Keck observatory with its cutting-edge adaptive optics. 11 of Uranus's 13 recognized rings can easily be seen in this Webb image, and since they are so bright, some of them even appear to merge into a larger ring. Apart from the rings, JWST successfully photographed many of Uranus's 27 known moons. Only 6 brightest of the moons are visible in the wide view image by Webb, since the majority of these moons are too small and weak to be seen in an image. Uranus rotates at a nearly 90-degree angle from the plane of its orbit, which results in harsh weather conditions. Uranus takes a total of roughly 84 Earth years to orbit the Sun, and as seen in JWST photographs, it is currently late spring at the northern pole of the planet. In comparison, it was summertime in the South Pole when Voyager 2 traveled to Uranus, whereas the South Pole is currently hidden from view and facing the gloom of space on the dark side of the Earth. JWST's near-infrared camera, also known as NearCam, combine data from 2 filters with 1.4 and 3.0 micron resolutions in order to create this mesmerizing image. The total exposure time for this image of Uranus was about 12 minutes. Interestingly enough, the generated image shows the planet to have a blue hue. This is interesting because when Voyager 2 turned to face Uranus, its visible light camera captured a nearly featureless blue-green orb. The details. Webb's increased sensitivity and infrared wavelengths has enabled us to see more details of how active Uranus's atmosphere actually is. At the right side of the planet, we can see a polar cap, or a region of brightening where the pole faces the Sun. Unique to Uranus, this polar cap appears when the pole is exposed to direct sunlight in the summer and disappears in the fall. The polar cap's slightly enhanced brightness in the middle is a truly startling feature. In the coming weeks, we may be able to spot this increased Uranus polar feature with Webb's NearCam, even if it has not been detected by other potent telescopes like Hubble Space Telescope and NASA's Keck Observatory. Thanks to this knowledge, scientists will be able to better grasp the mechanism of the planet once they have more information from Webb. Furthermore, on the left side, a second very bright cloud can be seen along with a bright cloud at the edge of the polar cap, as well as a few fainter extended structures just beyond the border of the cap. Such infrared spectrum clouds are common for Uranus and probably indicate the presence of storms. All in all, this is merely the tip of what Webb is capable of. It is safe to say that you can expect a lot more in the coming days as further research on Uranus is now being conducted, and more is being planned for Webb's first year of space operations.